In this example, I want to go over you doing composite functions and also figuring out the domain of the composite function once we've done so. So what we have here is f of x is equal to x over x plus 2. That's our function f of x. And I've already found the domain of this. This is negative infinity to negative 2 union negative 2 to infinity, which means basically that all values other than negative 2 will work here. Those are in the domain. And I've also done g of x, which in this case is 2 over x. And the domain for this one is negative infinity to 0 union 0 to infinity, which again is the same as this, with the exception of now it's 0 that can't be included here. Let's figure out how we first do the composite function of these two. We'll do f of g, g of f, and g of g as examples. And then let's talk a little bit about the domain when it comes to doing this, because there is some things to keep track of when you're dealing with that. So let's first find this composite function here. What I'm going to do here is I'm going to plug in 2 over x everywhere I see an x. Okay? So this would become 2 over x here also, plus 2. So I just took these x's and I evaluated them at 2 over x. Okay. Now let's get the common denominator on the bottom, which is x. Let's write this. If we do some algebra here to get a common denominator, we would end up with 2 plus 2x over x. When we're dividing two fractions like this, what can happen is we can flip and multiply them. So we'll do that here. We'll get 2 over x times x over 2 plus 2x. And we can see that those x's clear out there. And so we're left with 2 over 2 plus 2x. And we can factor this out a little bit, where we'll be left with 1 over 1 plus x. By factoring this 2 out, right? By factoring this 2 out, we would have 1 plus x, and then these 2's can divide out, and that's where I got this. Now, dealing with the domain here, first off, we have to examine what's the domain of this. Now, the domain of this one is negative infinity to negative 1 union and negative 1 to infinity. That is, if we were just looking at this by itself somewhere else, that would be what the domain of this function is. However, because we've evaluated g into this, we plugged g into our function, we also have to take into account the domain of g. Okay, the one that we're going to plug in to the other function, we need to look at that domain as well. So not only can x not equal negative 1 here, but x can also not equal 0, because if x is 0, we have a problem from the beginning. We would have 2 over 0, and already we have an issue going on because that won't work. And we can also not plug in negative 1, because when we do that, we'll get 0. So we got to take into account both. So the way that we would handle this is we would say negative infinity, and we can't be negative 1, so we've seen that. Also negative 1 to 0, also 0 to infinity. So the domain includes all numbers up to negative 1, all numbers in between negative 1 and 0, and all numbers beyond 0. Very important to note. Just looking at this, it looks like this would be the domain. However, because of a composite function, we have to look at the domain of the function that we are plugging in to the other function. And I'm putting quotes up when I say it like that. All right, let's look at now g of f. Okay, so now for g of f, we're going to take our g here, which is 2 over x, but instead of the x, again, we're evaluating it at f, so we have to put it like this. Okay, and now if we were to do some algebra here, technically this is like saying 2 over 1, and if we flipped it and multiplied, we'd have 2 over 1 times x plus 2 over x. And so what we'd be left with here is 2 times x plus 2 over x. That's what we would have as our composite function, okay? Now looking at this, what we see is that in this particular case, the domain can't equal 0, all right? And we can see that pretty clearly because we cannot have 0 in the domain. The 0 is not in the domain because x cannot be 0. So our domain is this. But because we're doing a composite function, we have to check the domain of this one as well because this is the one that we plugged in. So not only can x not equal 0 here, x can also not equal -2. The domain is all numbers up to -2. Then we have to skip that one. And we say that all numbers in between that to 0, and we have to say everything beyond 0, not including -2 or 0. So this would be the domain of this one. Okay, so f of f here, what we would have is we have to take f, and everywhere we see an x, we plug in f. And this one gets a little tedious to do, but we can do it. Let us first get a common denominator at the bottom here. So that would give us x over x plus 2. And doing the common denominator part here, we would have x plus 2 times x plus 2 all over x plus 2. Okay? So now that we have that, what we would need to do is flip this and multiply it. Well, I guess we could simplify this first. What we'll do is we'll say that this is x over x plus 2. All right? And this is all over, distributing here, well, this will give me a 2x plus 4. So this will become 3x plus 4. Okay? And this is going to all be over x plus 2. Right? Move that up for you. So this is it's going to be x over x plus 2 over 3x plus 4 over x plus 2 when we do the distributing here. And this we can flip now and multiply. And when we do so, when we flip and multiply, these x plus 2's will cancel and we'll be left with x over 3x plus 4. So I'm going to make some room here and then we'll find the domain of this. Okay, so we found out that f of f is going to be this. Now what we need to first note is that if we look at this denominator, we don't want this to equal 0, right? We don't want that. So doing the algebra here, subtracting the 4 and dividing by 3, we see that x cannot equal -4 over 3. All right, when you subtract this and divide by 3, that's what you'll get. And to write that in interval notation, -infinity to -4 over 3 union -4 over 3 to infinity. All right, so that's an interval notation. Now, let's take a look at the domain of this as a function composition. we have to account for the function that we have plugged in. That's this. So not only can x not equal negative 4 over 3, x can also not equal 2, because this is the function that we plugged in. You need the domain of this. What you need is the domain of this function that you see here, plus as well as the domain of the whole entire composition. We'll say, all right, x cannot equal negative 2. We also can't be negative 4 over 3. Either. This would be the domain for this composition. Finally, let's do g of g. Okay, so g of x here, we're going to take g of x and plug in g where we see x in the original function, so we're going to plug g right back into that. Now, doing the algebra to flip and multiply, that's 2 over 1, so I got 2 over 1 times x over 2. We see the 2's will cancel out, and so we're left with x. Now the domain of x itself, if it was just x somewhere and it was a function and it was f of x equals x, we know that that can be all real numbers. But remember, you have to include the domain of what we're plugging in. So the domain here would be negative infinity to 0 union 0 to infinity. So in summary, when you're doing these types of problems, after you've done the composition themselves, to find the domain, you always need to incorporate both the domain of what you found with the composition and the domain of which function that you plugged in.